Looks like everyone's coming online here.
Yes.
Madeline, you're in a basement now?
Oh, I'm always in my basement.
Oh, okay.
With my parents' basement.
All right. Ray was doing yoga or something. All right. Helps me comment to see you guys. I'm just happy to see everyone looking well and being here still. So this is coming in. All right. Sonia's got a power back on. All right. Excellent. Just got to find my folder of stuff here. All right, let's see who we got on here. All right, we got Madeline on here. That's the wrong class. All right. I don't know if I had the right class here. All right, let's see. Okay. Let's do it that way. Sorry, still organizing a little bit myself here. So let me see here. All right. Okay. And Jenny's here. Great. Ray's here. Awesome. Sonia. Liz. And Owen's here. What's up, Owen?
Hey.
That was kind of deep. Darina's here. Excellent. Hey, Darina. Hey, Giovanni. Christina. Hello. Aaron. Hello. Whit. Hello. Arielle. Hello. Miranda. What's going on? All right, let's go ahead and get started. So today, this Q&A is to prepare you for the exam. So I've got the exam ready to kick off on the D2L site here at 8 p.m. So it should become active in the announcements, and I will also send you an email through D2L that will have it attached. So Aaron, I'm looking at you, even though I'm not going to see your picture, it's going to be attached. So hopefully you'll be able to find it. But it's roughly 10 questions. You'll do 8 of the 10 if you want to, or you'll do 10 of the 10. It really doesn't matter to me which one you do. If you choose to do 8, just make sure that you put skip on the ones that you want to skip. If you choose to do all 10, I will skip your worst ones for you. And then I thought about it, and I'm going to be extra generous here. And so it is due back in my inbox by 2 a.m. Hopefully it won't take you that long, and you'll be sailing in a couple hours, if not sooner. But if not, if you thought you have the time, I need it by 2 a.m. That's the cutoff. So every hour after 2 a.m., I'm taking away 10 points from the total. So try to have it there before 2 a.m. And again, if that means you need to, hopefully you can print it out and then work on it that way. And if that doesn't work, that's fine. You should be able to at least bring it up electronically, take out a piece of paper of your own, work through the questions, and then either scan it back in or take pictures of it and then send me that. So it doesn't have to be, in the answer space I provide. If that's not big enough, you can use your own paper and send me that back. So if you're going to take a picture of it, just take like one picture per page. I think it's 3 pages long or so, and send it back that way. And if that means 3 emails, I'm fine with that too. But you should hopefully be able to stick them all in one email. So does that make sense to everybody?
Mm-hmm. Mm-hmm.
All right, good.
Yes.
Now, I know you're nervous about it. I mean, it's a test, and tests are important. And hey, there's Oscar connecting. All right. But here's the thing. I want you to do your best. And remember, I'm still the one that grades it. And I'm going to take your work with a grain of salt. All right. So I may not grade it as strictly as I would have graded previous exams or our one previous exam, because when I could be there and help you in person and that kind of thing. So just do your best. Remember, you can use your book. You can use your resources. and you can, put stuff down. And I think that will be helpful too. This is kind of algebra based. Owen talked about an algebra calculator. I guess I have no qualms with using it, but once again, what I'm going to be looking for is the work. If you put the answer down and the work isn't there, it makes me question how you came up with said answer. And so I wanted to see the work. The work is just as important as the answer, in my opinion. So once you give me an answer, I want to see the work on how you got to that answer. And the work shouldn't say, yeah, I used the algebra calculator. This is what it says, right? That's going to be like, okay, I'm not going to give you very many points for that, because that's not you doing your best effort, right? You're supposed to learn this material to a certain degree. Again, make sense to everybody?
Mm-hmm. Yeah.
Oscar, you good with that?
Yes.
All right. All right, so what questions do we have about the test coming up? I gave you problems to study from last time. What questions do you have that you want me to go over in the time that we have here tonight?
I wanted to look at 7.5.
7.5? How dare you? No, I'm kidding. What specifically in 7.5, Jenny, that is giving you issues that you want to look at here?
Well, it's because I wasn't here the Wednesday that we did 7.5.
Ah, yes.
So I haven't done 7.5 at all. And I was looking at it and I was trying to comprehend what was going on. And I was just really confused.
All right, let me see what we've got here in 7.5.
I had a question about 7.5 too, for example 6.
All right, well, that's a good place to start as any, I suppose. So this was our using the variation, right? Direct variation, joint variation, and indirect variation. And I know you weren't there, Jenny, but the joint variation has nothing to do with, that kind of joint. All right. So different kind of joint. All right. I was leaving class later and then going, yeah, they talked about joint variation, some sort of.
Oscar's done. He's like, I didn't mean to hear that.
I know. I'm like, what is that?
Hey, I got nothing against that. It just doesn't have anything to do with this kind of variation, all right? So
Right.
I can't tell you over the years how many times I've talked about joint variation that someone's gone, yeah, later I did some joint variation. And I was like, oh, so what problems were you using? And they're like, problems? It was rolled up. It was that kind of joint. Like,
Oh my God. You're like, okay, cool. You.
Okay, that's not really doing variation on a joint. I mean, you'd have to have a big one and a small one. Forget it. All right.
Oh
All
my
right,
God.
so let's see if we can find a problem that's similar to example 6 of one we haven't done yet, so we get some extra experience in it here. That has, is there any good stories that we have with it here? Let's see, maximum strength of the spring. No, doesn't gliding.
16.5.
Braking distance of a car. No, calculate amount of feet needed. Estimate wildlife population. Strength of a beam. No, I got a lot of strength of beams on his. We need something more than strength of a beam, because as fun as that is. All right, I guess let's try like 40. I don't think we did 49 as part of our homework set, did we, on page 357? So let's give that a try and see what that looks like here. So let me bring up the whiteboard.
What number is this on 57?
It says 49. It says finding gas pressure. I'm hoping this is going to work. Let's see here. If the temperature is held constant, the pressure of gas in a container varies inversely as the volume of the container. All right, so remember, these problems are done in parts, right? And part 1 says, write the equation that we've got there. So temperature is what we're starting with. So we're going to say that temperature equals, because it says temperature is held constant. The temperature, let's see here. Oh, not temperature, sorry. We don't want temperature. It's really pressure. This was kind of an odd problem here. Let's try that again. All right, so let's try it again. And this time it's pressure is what we're looking for. So the pressure, here we go, of gas in a container varies inversely. Now, inversely means that it's going to be underneath our K. let's see here. The volume is what we're looking for. All right, so we're going to start this problem as P equals K over V. Now, K is in every problem, right? K is the constant of variation that makes each problem work. It's there in every problem, but it's not the same value in every problem. But the value itself, K, is in every problem. It's the constant of variation, right? Every problem has a different one that makes it work. But the first step is always write the equation out as you see it. Anything inversely goes in the denominator. Anything joint or direct goes in the numerator with the K. Sometimes there is no denominator. If there's no inverse relationship, then you're going to have K and a bunch of letters in the same line as K. You know, if this said very jointly as volume and temperature, then we'd have K and V and T all in the same line. But because this one said inversely, then we're putting the V down. So step number one is just that, write the equation out. Step number two says, hey, they're going to give us some data. In fact, they're going to give us data for V and P in this case to let us calculate what our K is. So if we read further in the problem, and I think that's the mistake a lot of people make on these problems, is they want to read the whole problem at once. And you don't want to do that. You want to do is you want to read it piece by piece. Read it just enough so you can write the equation, stop. Then read the next piece. So here we go. It says, assume that the gas pressure, so the pressure in a large piston cylinder is 4 pounds per square inch. They're telling us that the P is 4 after all that nonsense. Again, the K we won't know, so we can put that here. And then they should give us the volume here. When the volume of the cylinder is 120 cubic inches. Perfect. So now we're going to put down 120 right there. So we put in the two facts that we know. And again, stop. Don't read further. Figure out what the K is at this point, right? Now, for us to be able to do that, we're going to have to multiply 120 times both sides of this equation because 120 is in the denominator. That's the only way we're going to be able to get rid of it. So put a little dot here that says times 120 here and a little dot here. And we'll say times 120 over here. Now, the 120s cancel on the right side. That gives us just the K, which we're trying to solve anyway. And K is equal to 120 times 4. That's going to be 480. So now we know what K is. Great. What I usually do is I got to go back to the original equation and I say P doesn't equal K over V. P equals 480 now over V because we know what K is. Might as well put it in there. So then the last part of this problem on any one of these variation problems is always the same way too. They're either going to ask for P or they're going to ask for V. They're going to ask for one of the letters that they didn't give you the first time. All right, so let's see here. If the volume of the cylinder is reduced to 75 cubic inches, what is the pressure of the gas? So they're telling us the volume. So this problem becomes P equals 480 divided by 75.
Wait, where did we get the 75 from?
Because it's asking for 75 cubic inches,
Oh, okay.
which is
Oh, I see it.
Yep, you're right. It's right. It's in the problem. Exactly. I didn't just pull it out of thin air. Madeline's thing is exactly right. It's in the problem. So, and then we solve this. Now, I don't believe 75 goes into 480 evenly. In fact, I'm pretty sure it doesn't. So that's when we take your calculator out and you say, hey, calculator, what's 480 divided by 75?
6.4.
It's correct. 6.4. So we'd say the pressure equals 6.4. And let's see, what kind of unit did they assign pressure the first time? They said pounds per square inch. So we'll do the same thing. So LB's pounds per square inch, IN2. Or you could just write it out. You could say pounds per square inch, but that's sort of shorthand way of saying it. Because in the end, you do want to give context to what this pressure is. And it usually gives it to you as part of the problem, right? It says pounds per square inch. So we'd say that. If they were looking for volume, we would say cubic inches or IN3. That's a cubic inch. But again, you could just write it out if you want to. But that's sort of important at the end to give it context and say, because at the end, you'd say 6.4 what if you didn't have the context, right? We talked about context with the first test and some of your answers when I'd say, what are you talking about? You know, dollars, you know, whatever. So same thing goes here. Ray, does that make you feel better? Jenny, does that help you a little bit?
Yeah.
Kind of.
Kind of. It's like, well, can I see the one on the test? No, but
Exactly.
you will shortly.
Why don't you pick what you think is going to be the most difficult one on the test, and then just give us another version of that problem?
On the test?
I think what's difficult for everybody, though, Ray, is slightly different.
That's true. Well, what do you think is the most the most steps that we're likely to make mistakes? I'm sure there's a problem on there with a lot of steps, and if we just could do a similar version and refresh the steps, I don't know. I trust your judgment.
That's when you just skip it at that point. You get 2 skips, so you might as well use them. If you look at it and go, no way in heck do I want to do this problem. Or like in Jenny's case, if she sees something from 7.5 and she says, this makes absolutely no sense, I'm skipping this one. So she's got that out.
Definitely.
But let's go ahead and take a look, because Jenny asked, let's go ahead and take a look at example 1 or something similar to example 1 on page 350 from 7.5. Just as a refresh on this, and hopefully for Jenny, a learning experience along the way here. So this was doing ratios, right, and proportions, and setting up things and cross-multiplying to solve. All right, so let me see if I can find something that is, again, similar that we haven't done yet, that just gives us a little bit of extra fun for it. So let's see here. Let's do number 4. That looks like a pretty decent problem. So exercise number 4 on page 355. All right, I'm going to go ahead and clear this screen here. Maybe. No. All right. Anybody seeing that my meeting will end in 10 minutes? That can't be right. We need to start.
Yeah, it's only 30 minutes long.
Oh yeah, well we got that. We can get through this problem.
All right. We'll get through this probably real fast. We have to redial, or if I have to restart it, we'll do something, I guess. All right, so let me clear all these. All right, so number 4 on page 355 says x over 8 equals 14 over 4. All right, so this is what they call a ratio or a proportion problem, in that one fraction equals another fraction. And it equals, it has to equal. So for us to solve it, we just cross multiply. So we're going to cross the 4 and the x together. We're going to cross the 14 and the 8 together. Now 4 times x is indeed 4x. That's the fun one. And 14 times 8 is more of a calculator problem at this point. I don't know what 14 times 8 is. Oh, it's 112. So let's put that down. 112 is the answer on this side. Again, that is 14 times 8. And then we divide both sides by 4 to achieve our answer here. And x in this case is going to be 28, I think. Hopefully that's
what
right.
I got.
That's what you got? All right, perfect. I was doing that one in my head. So, because I know that 4 goes into 125 times, and 4 goes into 12 3 times, and 25 and 3 makes 28. So that's how I arrived at that total myself. But yeah, I don't see anything harder than this when it comes to ratios and proportions on your exam. It may not give you a nice 28, but if you follow the method, it'll give you whatever it gives you. So,
Okay.
Righty.
and hopefully that should be one that nobody skips.
Yeah, it seems fairly straightforward.
I mean, there's probably a couple on there that even I would skip, and I wrote the test, but this definitely wouldn't be this one. This kind of problem, I think, is of a nice, easy variety there.
You could just multiply the right side by 2 and then get rid of the fractions as well.
You could do that, sure. As long as you multiply it by 2 over 2, then you'd have the same denominator in this particular case, right? That'd be both be 8. So what that statement was is if we multiplied this by 1, and the form that 1 takes is 2 over 2, that would give me the same denominator as an 8, and then we'd be able to say our numerators have to be the same as well, because 2 times 14 is 28. That's certainly another way to do it. Again, the big thing for me on your exam is show your work. I don't care how you do it. I don't care which way you do it. There's many ways to get the right answer to this problem. Just show your work. Show your work. You can't go wrong. Well, I mean, you could still go wrong, but at least I'll know where the work is, and you'll at least get half credit. So there you go.
Okay.
What else do we have?
Maybe we might do another quadratic equation, because that's like one of the longest steps out of these chapters that I could probably think of. I see Oscar nodding over there.
Yeah.
There's a lot of steps in those, so maybe just one little quadratic refresher. If we have that on the exam, I'm sure.
All right, well, let's just make up one then here. So we're going to say that, let's see here.
What section is this usually in?
This is from 7.3 or 7.4. Let's see here. 7.3. Yeah. Yeah. And a specific I'm going to do is the solving of a quadratic. So this is similar to example 3 on page 329, the solving of a quadratic here. So I'm just making one up as we go because the quadratic formula is beautiful in that it'll work for anything. So let's do 2x squared plus, I don't know, 7x plus 3 equals 0. And we'll say solve. Oops, I hope I can spell solve right. There we go, solve. All right, so we want to identify what's a, b, and c, right? So what's in front of the x squared is the a, so a is 2. What's in front of the x is the b, that would be that b is 7. And then the thing that doesn't have an x, that is the c value, also known as the y-intercept as well. All right, so then we have that. We do the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so then we say x equals, our b is 7, so it's a negative of 7 plus or minus the square root of 7 squared minus 4 times a.
Wait, let me just catch up on all this typing. You're going too fast, and then my brain gets lost. Just give me like
I'm just putting in values right to the quadratic function. That's all, the quadratic formula here. B is 7, C is 3, A is 2, and I just put those into the quadratic function here. Now we put it together, right? Negative 7 is negative 7. So in that case, nothing's going to happen to that value. So that's still going to be over here, negative 7. And still plus or minus. And then here's where the fun takes place, inside the radical here, inside the square root. You got 7 squared. That should be 49. You've got a minus, and then I always do the sign next because I got a minus here, which is minus 4, and a positive 2 and a positive 3. So a minus times a plus and a plus is a minus. And then you've got 4 times 2, which is 8, and 8 times 3, which is 24. And then all divided by 2 times 2, 4. Now we can go ahead and do the subtraction inside the radical. 49 minus 24 is 25. Oh, this worked out better than I thought. I just made these numbers up. So you've got negative 7 plus or minus the square root of 25 over 4. We happen to know what the square root of 25 is. What's the square root of 25? Anybody?
5.
That's right. 5. So now we're at this stage, negative 7 plus or minus 5 over 4. And there's 2 answers here, right? One answer is negative 7 plus 5 over 4. Let's get that down here. And the other answer is negative 7 minus 5 over 4. And then we want to see if we can put these together in some sort of meaningful format. You know, negative 7 plus 5 is negative 2. Negative 2 over 4 is the same thing as a half. So there's one answer, x equals a negative a half. Here we've got negative 7 minus 5. That's going to be negative 12. And divide that by 4, and we're going to get negative 3. And so both answers are negative, but one's negative a half and the other one's negative 3. You would use the same process if you were graphing the quadratic when you found the x-intercepts, because another thing that this would be useful for is to tell us that the x-intercept is negative 1/2 comma 0 and negative 3 comma 0. It's just about context. This one says solve, and so that's why it only has the answers in this format. But if it was for a parabola we were going to graph, then you would do the same process and you would just say, hey, the x-intercepts are negative 1/2 0 and negative 3 0. But same process. Nothing changes except for the final piece of it. Ray, does that make you feel a little better?
A little bit. You just go so fast that all I'm doing is just copying numbers down rather than like processing. It was just like one notch slower, then I could actually process more what's going on. But still, the copying helps. At least, you know, robotic learning, sure.
Okay. Well, you know, I did post our first video up on my YouTube channel from our discussion last time, and I apologize again to the lab people for whatever reason that it wasn't set to record, which has been fixed for our next lab. But this, I believe, is recording. And so we should be able to put this up there as well. So if it was too fast, Ray, you can go back and watch it one more time and get it. But the thrust of it is this part right here, the quadratic formula.
Right.
A lot of this is very formulaic. Knowing what A, B, and C are and just shoving it into the equation and seeing where it comes out.
You know, it was helpful. Thank you.
I mean, that's the goal of this, right? Is not just to have you show up and do nothing. I mean, you paid for this experience. So it looks like I'm getting 1 minute and 9 seconds left on my thing here. So I'm going to have to investigate why our time started earlier than I thought or something here. So and maybe it starts when the first person gets in and I'm letting you all come in before I come in, and maybe the clock starts then, because technically we only get 40 minutes. So unless I pay for this, and I'm not planning on doing that anytime soon. School doesn't pay me that much money. So all right, so any questions in the last less than a minute remaining here on this particular session?
Are there still only 12 questions?
It's 10 questions, Oscar, and you'll do 8 of those 10, or you'll do all 10, and I'll skip your boards too.
Okay.
All right, then. So it's almost 8 o'clock as well, so I guess wait for a couple minutes here, and then it will post on D2L, and I will send you an email as well so you have everything there. All right, good.
Thank you.
All right.
Thank you.
We'll see you guys. Bye.
Bye. Good luck, everybody.
Good luck.
Good luck.